Okay, let us begin. We have that we stopped last time. What is it right here? So sometimes they might ask you to, they might give you, might ask you to find the X value, call it the data value. So we use this method, finding data values, giving specific probabilities. And the formula we use is this formula here. X equals Z times standard deviation plus mean. So all you have to do is to find the value of V, the value of Z, and with that you can find plug it in, and with other values into this formula, you get your value, data value you're talking about. So let's see how this can be applied. Okay, it says to qualify for a police academy, candidate must score in the top 10% on a general ability test. The test has a mean of 200 and a standard deviation of 20. Find the lowest possible score to qualify. Assume that the test scores are normally distributed. Okay. In that case, you have solution. Okay. Yeah, the mean is 200. The mean is 200. Let's put mean. Okay. Insert mean. Mean is 200. And they also give us the standard deviation so that we have mean equals 200. Standard deviation equals 20. Now, I said to qualify, you must score in the top 10%. This is where we need to find our Z. To have draw our charts. So 4. So top 10%, that means your score will be bigger than the bottom 90%. Okay. So this is the we don't know the value of, excuse me, have 0 here. Top 10%. We don't know. That's our X here, so that we can put our a little bit down, a bit. Okay, that's good. So we can put our X-axis. So top 10%. Again, top 10% means that your score is bigger than the bottom 90%. So the top, so it's top 10%. That should be around here. So 90% will be below your score. This is top 10%. This is a cutoff point right here. So that's to give you the highest score to qualify. Say top 10%. The whole of this place should be 90%. Okay, but yours is on the top 10%. So you got to say that top 10%. I'm gonna write this here. Okay. Top 10%. So should be around here. All right. It's on the tail. See? Oh, my mistake. I put the wrong with this. So the top 10%. So this is actually have the top 10% right here. Okay. Now that means you are shed this part. Okay. All right. So to get all this, you know that when it's at the tail, you subtract. Okay. The score had to fall here. Where's this thing coming up? Okay, shit again. All right. Okay, the last one. All right. So top 10%. So yeah, Z will be because it's on the tail. To get your Z, maybe I should move this down. Let me move it down. Because we don't have enough room here. So now move it down. From here, I move it down. Top 10%. Yeah. Now, your Z will be, to get Z, have 10% is 0.1. So because it is at the tail, go at the 0.5 minus 0.1%. I mean 10%, which is 0.1, which is give us 0.4. Then you look for this 0.4 in the table of normal distribution. So we go to table of normal distribution, look for 0.4. We could not see. So we didn't find 0.4. We just have 0.4 something. So, but we get 0.3997. Then this one is 0.4015. This one is 15 points away. But if you check it with the calculator, you see that this one is only 3 points away. So this is closer to 0.4. Then you follow it to the left. 1.2.
Excuse me, Professor. What are we looking for?
Huh?
What are we looking for? Are we looking for 0.4 under what?
0.4000. This time you're looking inside, you're doing it inside the table. You're not looking at this because they gave you the probability already as 10%. So
okay.
Then because they give you a 10%, I say the top 10%. When you draw the chart, your chart looks like this.
Yes.
It's on the tail. So you're looking for only this part. Remember, the whole of this part is 0.5. So you have to subtract it from 0.5 to get 0.4. Then look for 0.4000 inside the table. I put this 40 because inside the table, all the numbers, they have 4 digits. Okay. So this is the closest here. This one is 550. If you sub 0.40515 minus 4000 is 15 points away, too far away. But this one is only 3 points. 4000 minus 3997 is 3. You can double check it from your end. Then you follow it to the left. You get a Z, 1.2 and up 8. That gives us 1.28. Okay, 1.28. With this now, you can answer the question. But the question we're asking you,
I don't understand it.
Find the lowest possible score to qualify. They give you the mean, they give you the standard deviation. Now you have to get they give you the percentage, which is the probability. So you follow this to get your Z value. Now to answer the question. So the lowest possible score to qualify, the lowest possible score is given by this formula. This is the formula right here, X. So which give us equals Z is 1.28 times our standard deviation, which is this one, is 20 plus the mean, which is 200. So let me make it this bigger so we can see it very well. Make it 16. So, and that will give you the lowest possible score to qualify, which is, let me write this down, about 1.28 times 20 plus 200. So I'll go to a calculator and I'll find 1.28. 1.28 times 20 and plus 200. 225.6 points. 225 points. That's it. That will be the lowest score to qualify. That means the cutoff score. So anybody that scored as 225.6, 225.6. Anybody that have that score will qualify to be in that academy. 225.6 points. Question?
Excuse me, Professor, I have a question. I'm taking you back to the table. I don't understand how we got the 1.28.
Yeah.
On the table, you checked is 0.4 under 0.
No, that one is if you're looking for Z score. You're looking for Z. I'm sorry, if they give you the Z score. They give you the Z score. Like here, where you have the Z, you have the Z score. And they ask you to find the probability. That's when you're gonna look. But here they give you the probability already as 10%. So you're doing the opposite. You're looking for the Z score this time. You're not looking for the probability. So in that case, what you're gonna do is to look inside the table.
Okay.
So we get this is the number that is closest. So we follow it to the left. At 1.2. Up 8. So this time around, you're looking for Z score. You're not looking for probability. If you're looking for probability, let's say that they give you a Z score of 1.28. 1.28, then you look for 1.2 under 8. But this time you don't know what the Z score is. So you're looking for it. So you look inside the table and do the opposite. Okay?
Okay.
Now look at the second example, because I can ask you in different forms. Look at this one. It says here, for a medical study, you have medical study is a researcher wishes to select people in the middle 60% of the population based on the blood pressure. If the mean systolic blood pressure is 120 and the standard deviation is 8, find the upper and lower readings that will qualify people in the study. Again, you are given the probability at 60% already. So this time you get your Z score and then find the X value. This time there are two X values. They say the upper and lower readings. So again, the mean is given as the mean and the standard deviation we are given. And standard deviation we are given. So the mean is given us, the mean is 120. And standard deviation is given us 8. I'm gonna make this big. Okay. That's 8. Now, then we need to find the upper and lower readings. That means X1 you don't know, and X2. We need the upper and lower readings. Now, to find that, we need Z1 and Z2. And Z2. So we need both to, to be able to answer the question of lower. So Z1 will be used to get the upper reading S1, sorry, lower reading S1, and Z2 for the upper reading. Let's see. So next thing you do is to draw the chart. Okay. Now, this time around, you say the middle 60%. But this thing have two sides, lower side, the left side and right side. So the middle 60% means that there'll be 30% on both sides. Yeah. So one would be looking for X1, X1, 0, and X2. Okay. So our Z1, you can get it from here. Now, let's finish the drawing. I'm gonna put the X-axis. Okay. I think I didn't get it right first time. So the X-axis right here. So I'm gonna bring it down a little bit. Okay. Now, then of course the center line. Now it says the researcher wishes to select people in the middle 60%. That means we have two sides, left and right. So middle 60% should be 30 on the left side and 30 on the right side. So we have 30 on the left side and 30 on the right side. And so in this case, they're already added to get 60%. So that means 30% here, 30%, and 30%, making it 60%. But there are two sides, so you're gonna share the two places. Okay. So like now, it's already added to get 60% because they made it 60. So you don't need to start subtracting or adding anything because it's already done for you. So you go direct to the table and get your answers. Okay. Okay. So this is 30% and 30%, which is 0.3 on both sides. 0.3 on both sides. Okay. Never cross the boundary. All right. The computer is sometimes messes up. All right, we have this. Okay. Now, Z1, to get Z1, you get to the table is 30%. Is 0.3. There are 4 digits on the table. All the numbers on the table have 4 digits, so you can make 0.3 and can be a 0.3000. Now let's look for this on the table. 0.3000. 0.3. What number is correspond to 0.3000? So 0.3051. This is another 0.2995. Then we have 0.3023. These are the closest, the number that are close to 0.3000. For this one, if you look at this, 3023 minus 3000 is 23 points away, too far away. On cap, this one, 0.2995. You can check it. 3000 minus 2995 is only 5 points away. So it's closer than the other number, which is 3025. So this one is closer than this one. This one is, if you do it 3023 minus 300, you can see it's easy. The subtraction is 23 points away, but this one is only 5 points away. So this is closer. You follow it to the left, 0.8, then up, 4. So you have 0.84. So we have 0.84 Yeah, 0.8 under 4. Yeah, 0.84. So have what is my 0.8? What is my what book? I think this is it. So 0.84. No, you know that the z value for z1 is for x1, so it's on the left side. So you're going to be negative 0.84. Now z2.
Please, Professor, how did you get the 4 at the back of 0.8?
The 4. We look at the table. So you know how you get 0.8, right? You know how you get 0.8.
Yes, I know that.
So follow it up. See,
Oh, okay. Oh, okay.
Here for this one is on x2, which is on the right side. So it will be by symmetry. By symmetry, remember, halfway is the same on both sides. Halfway because there's symmetry. So by symmetry, z2 will also be 0.3. As you can see right here, 0.3. We say in the middle, 60%. But the only difference is that now, because it's on the right side, it's going to be negative. It's going to be positive. So we have our z1 or z2. Now we can now find the required upper and lower readings. So the upper reading or lower reading are x1 equals, okay, excuse me, mistake, equals x1, sorry, z1 times mean of mu. Sorry, times standard deviation, not mean. Times standard deviation plus the mean, which is this one. So plug this in. Our z1 is negative. So negative 0.84 times standard deviation. Our standard deviation is given as 8 plus the mean is given as the mean of 120. So let me write this down. Negative 0.84 times standard deviation of 8 plus 120. So I'll take you to the calculator. Okay. So have negative 0.84 times 8. Okay, plus 120. 113.28. Millimeter of mercury. Those of you in the medical field, you know that blood pressure is on millimeter of mercury. Measure it. So you have equals 113.2 millimeter of mercury. Now for the upper side, this is for the lowest reading. For the upper reading, it's the same thing, except that this time we use an positive. So I call this one upper reading. So we have x2 instead of x1. So it's going to be z2, which is positive. So just remove the positive sign here. The negative sign here, so that we can get our answer. So we go to our calculator and then put the number in. Remove the negative sign. This is 126.72. So 126.72. Yeah. 126.72. So this is lower readings, upper reading. So for the question was if the mean is 120 and the standard deviation is 8, and the researcher is using 60%, the middle 60%, which is middle here, 30, 60. So the amount of blood pressure to qualify, the upper and lower readings that will qualify people to participate will be 113.2 milliliter of mercury to 126.72 milliliter of mercury. Question on this? All right, good. Now this one, it says SAT scores. Suppose that SAT scores are normally distributed with a mean of 9 to I'm going to draw the diagram of this, so then you can practice this. It's just like this one is just like the first one we did here, like this one. So that here in this case, you use 10%. Here I'm going to use 5% because it says compute the 95 percentile score. The 95 percentile score the 95th percentile score is the score X such that 95% of the class, the values are below it. Yeah, of the scores are below. That's what it means. Which imply that we just draw the chart and follow the same process. The same process we did for the first example in this section. So if you make the chart, you're gonna have something like this. Okay. All right, you have it. Okay. Now we can have this number 0 for the center. 95%. I mean, it's just like saying the top 5%. So X is what you are looking for. Okay. Now you can put your X-axis. Okay, and then you have your center line of mean, and then 5% score will be here. And it's cost so that 5% is 5% is top 5%, basically what it means. I have it as top 5%. Top 5%. So I mean 5% of the scores will be below this top 5%, 95% scores. So this is a top 5% right there. So I said I've drawn the diagram for you. Let me share it too, so you can see the top 5%. So what that means, they say 95% score is scores so that 5% of all the scores are below it. So another one is we have seen it as the top 5%. Then you can start working on it. So you can see how we did the first one. The first one here is 10%. As it says, top 10%. Just like saying 90th percentile score, stuff like that. It's 95 percentile score. So I leave this for you. You can finish it up as a practice. So let us go to the central limit theorem and finish up. Central limit theorem, it says that basically what this is saying is that okay, we have 10 minutes left. What is saying that, say, let me move it down so we can have enough room. It says The central limit theory says that if you have a population mean of mu, well, I know you guys can read, so I will leave that for you to read. But what he's trying to say here is that as the sample size increases without limit, then the sampling distribution or the sampling distribution, yeah, it becomes normalized. Okay. Then, say you have a normal shape that it changed to this shape as the sample size increases. Okay. So we can apply this in solving a normal probability equation. That is, they give us the sample size, and then you can apply it. So, in other words, as the sample size become larger, assume all samples are identical in size, then, and if the sample size are taken from a population that is random, then the distribution of the sample mean will approximately they become normally distributed, approach normality. So the time we have on it will not allow us to finish it up on this section, but I will, let's see. Let me explain it. Then when we come back, and then we finish it. An example. So now, because the sample size and the sample mean are not included, yeah, we use the formula. This is instead of using this formula to transform. If you remember the original formula we used, transform is x minus mean over standard deviation. But when we are doing central limit theorem, the formula we use to transform, it becomes this one, x minus sample mean, actually x bar minus population mean, divided by standard deviation over square root of n, because the sample size is now included. So under the application, we use a different transformation formula. So this is not x, this is x bar. You can see right here, x bar. See, the sample mean, this is the population mean, population standard deviation on the sample size. So let's do one example on this, and then we finish. But because this time here, 7 minutes will not be enough for us. So I'm gonna.
Yeah, excuse me, Professor. Hello, Professor.
Yes.
Yeah, please. I have an issue on my what's it called? My Excel. I don't have a data analysis. Yeah.
I'll explain that. I will explain that when we finish the class.
Okay.
I want to time us out. We're gonna log back in again so we can finish this central limit theorem. So when we finish that, then we can ask that question. I will. So I don't know if you're following. Hello.
Yes, I do.
Yeah, I will time us out now. Then with 10 minutes, log back in so that we can finish this central limit theorem. It will not take long. It's basically the same thing. Then you can ask that question about Excel. We can show you how to add the data analysis file. Sorry, toolkit. Yeah, Excel. Okay. Oh, hello.
Okay, sir.
Hello. You still here?
Yeah.
The person that asked about Excel.
Yes,
Hello.
I'm still there.
I think you know what? I think we still have 5 minutes. It won't take time. So let's just do it with this 5 minutes. Then we'll come back and then finish it. Okay.
Okay, sir.
So if you have an Excel, I don't know the version you are using. But I'm going to use my own to show you. Then if it's not in your own version, then you might look for your version and see if you can watch it on YouTube. Okay. Now, you can see the screen now, right? Can you?
Yeah.
Okay. So maybe go to File, then File, and then Options. Can you see the screen? Option.
Yes.
Then click on Option. Then excuse me, hold on. Maybe check with something else smell. Oh, okay. Sorry about that, class. I was hearing a smell, something like something on the gas. So I want to make sure I'm safe. All right. Click on add in. Can you see that?
Yes.
So then click on go. Then once you click on go, it will give you this dialog box. Check this two box, analysis two part. There are two of them, check them both. And then click OK. So after you do that, once you click on data, you will see the data analysis toolkit right here. Or it might be somewhere depending on your screen, based on the kind of the version of Excel you're using.
Okay, sir. Thank you, sir.
You're welcome. So when I was saying that I'm about to time us out, so I'll explain after the. I didn't realize that we still have up to 5 minutes. So now I'm glad I answered the question. Now, so I'm gonna time us out now. Please log back in. We have a few things. Just the last example, which is the central limit theorem. So let's finish it up, and then we are done with normal distribution. Tomorrow we start confidence interval. Hopefully we can finish it tomorrow, and then do the rest of them, test of hypothesis. The class is almost over. I'm sure you must be excited. I'll see you soon. If you're in the next 10 minutes, please don't forget to log back in. We finish it up. I check your attendance and we'll go. Okay?
Okay.
Okay.
All right.